All right, guys, so today we're learning about something called apothems. They're part of regular polygons. And if you guys remember, a regular polygon is any polygon, which is a two-dimensional shape, where all the sides of that shape are equal. So for example, this type of polygon is a triangle. So this is not just any triangle, it's a regular triangle. That means that all the sides are the same. In other words, it's equilateral, right? So there are some parts of a regular polygon, and there are some patterns with regular polygons. There's only one area formula for any polygon that's regular. So that formula is the area of that regular polygon is equal to half the apothem times the parameter. So just a reminder, this is apothem, and this is perimeter, times the perimeter. Did I say parameter? Okay. So there are some parts of this regular triangle. So the distance from the center of the triangle that falls perpendicular to one of the sides, that is called the apothem. Okay. The distance from the center to one of the corners, okay, since all these sides are the same, it doesn't matter which corner you pick or which side you pick, they're all going to be the same distance. This is the radius. And the perimeter, as you guys know, is just adding up all the sides together. So let's do an example with this triangle right here. I was just labeling the sides. The only information given for this triangle is that this distance is 7 feet and that the distance of one side is 24.2 feet. Okay, and all I really need is that apothem and the perimeter. So I have the apothem, I don't quite have the perimeter, but I have one side. But this is a regular polygon, so if one side is 24.2, then all the sides are 24.2, right? And I can find the perimeter that way. So what I can do is I can just take 24.2 and multiply it by 3, or I could just add 24.2 plus 24.2 plus 24.2. It's the same thing. So first let's see, the apothem equals 7 feet. And the perimeter equals, let's try multiplying that. If I multiply 24.2 times 3 in my calculator, I end up getting 72.6 feet. Now I'm going to plug my values into my formula. So the area of this regular polygon, this triangle, this equilateral triangle, is 1/2 times the apothem, which is 7, times the perimeter, which is 72.6. Easy. I just plug that into my calculator, and I end up getting 254.1 feet squared, right? Because it's area, it's feet squared. All right, guys, if I follow the steps from my notes, the steps to find the apothem and or the side lengths. This only gives me the apothem, so I want to find a side length, okay? So it says step 1, create a right triangle by drawing the apothem and the radius. Well, I already have the apothem, I just want a radius. So I'm just gonna, and I want it to be a triangle, so it just can't be any point. I can't be drawing lines to these corners. I want to draw one right next to that apothem. So I can actually create a triangle, a right triangle, okay? So there's my right triangle. Here's my apothem. Here's my radius. So it says find the measure, step 2. This is what I'm reading. Find the measure of the interior angle where the radius intersects the vertex. Where the radius intersects the vertex. That's right there. And I want the interior angle, that angle right there. And you can find it by using the interior angle sum formula. So it says the sum of that interior angle is equal to n minus 2. So the formula is written a little weird on the actual worksheet. It says n minus 2 divided by 180 is equal to the sum of this whole polygon. I think that might be a typo, because if you guys remember correctly, the formula to find the sum of a regular polygon is n minus 2 times 180. So there might have just been a typo there. So remember that n is the amount of sides of a regular polygon, and we haven't done this in a long time. But this was a formula that we used. We found a pattern when we had different polygons. We like had a regular triangle, and then we had a regular, which was just a square. Then we had a regular pentagon, right, with 5 sides, and we kept adding a side to each one, and we kind of found a pattern to that, and we discovered this formula. N minus 2 times 180 is going to be the sum of all the interior angles. So I'm just going to go ahead and plug in n, or the amount of sides. This is a hexagon, so this has 6 sides. So 6 minus 2 times 180 degrees. So that's 4 times 180, and that should give you 720 degrees. So that means if I add up all my interior angles inside of this hexagon, the sum should be 720. And since all the sides are the same length, then all the angles are the same measurement too. So that means I'm going to divide 720 by the amount of sides that there are. Okay, so that's what your notes mean when they say divide by n. Okay, so I'm going to divide by 6. So that gives me 120 degrees. That means one of these angles right here is 120. Okay, and the radius actually splits the angle in half. So to find only that interior angle, I'm going to divide this 120 by 2. Okay, because I know half of 120 is going to give me that interior angle. And that gives me 60 degrees. Half of 120 is 60 degrees. So that interior angle right there is 60 degrees. The next step says use special right triangles. So these are triangles that have a measurement of either 45, 45, 90 or 30, 60, 90, or trig to find the apothem or the side lengths. So I want to find a side length. So I'm going to go ahead and use one of those two things. It says use special right triangles or trig. We use trig when we don't know the exact pattern. So since this is a special right triangle right here, it's a 30, 60, 90 triangle. Remember, there's a pattern, okay? So when I have a 30, 60, 90 triangle, let's say this is 30, this is 60, okay? So the shortest leg, oh, actually these are switched. This should be 30 and that should be 60 because the opposite of the smallest angle is going to be the shortest leg. So the shortest leg, if its value is x, okay, the longer leg, that's not the hypotenuse, the pattern it's going to have is going to be x times the square root of 3. And the hypotenuse is going to be double that shortest leg. So I want to find this short leg, x, because that will give me half of one of my sides, and I want to know the length of this full side. So I'm going to solve for x. Okay, so I have this long leg right here. Okay, so that is, if this matches that long leg, I'm going to set them up as an equation equal to each other. So I'm going to write in a different marker so we can kind of differentiate what we're talking about. So that means x times the square root of 3 is equal to 5 meters. Okay, that's that pattern that has. Now x is in my equation, so I could just solve for x and find the length of that short side. So if I divide both sides by the square root of 3 when I'm solving for x, and I just plug into my calculator 5 divided by the square root of 3, I should get approximately 2.89 meters. So this length right here, this half of my whole side length is going to be 2.89 meters. Okay, and I need that full side length to find the area of this regular polygon. So I'm going to find that full side length. So I'm going to double it. Since this is half of my whole side, I'm going to multiply this by 2. And when I multiply by 2, I end up getting 5.78. So that means that one of my sides right here, 5.78. Okay, doesn't matter which one because they're all the same length. Okay, I'm going to erase some work so that we can have more space on our board because we still have to find the area. I found out that x is equal to 2.89, which made one side, because I doubled that, it made it 5.78 meters. I have my apothem and I have one side. I want to find the area of the entire figure. So the area formula is area equals a half of the apothem times the perimeter. So I have my apothem, that's 5. I want to find my perimeter. I only have one side length. So the perimeter is equal to all of these sides added together. And there are 6 of those sides that are the exact same measurement. So I am just going to multiply 6 times that side length, 5.78. And that equals 34.68. So now I have my perimeter and now I have my apothem. Now I can plug it into my area formula. So the area equals a half of the apothem, which is 5, times that perimeter, which is 34.68. And that equals, when I just throw it into my calculator, that equals 86.7, and we're measuring in centimeters squared. So that is my final answer. So these are the steps that you need to take to find the area of a regular polygon when you're only given one piece of information, when you're only given either the apothem or a side length. And it just kind of requires a lot of steps, but I know you guys got this. You guys can do this.